students, the next topic is to predict the position of the element in the periodic table. And when we are predicting the position, for that we need to identify the block, then the group, and the period of the element in the periodic table. So students, whenever we are predicting the period, group, and and the block of the element, the first step is to write down the correct electronic configuration. So students, here I am writing certain points which will help you to predict the period, group, and block of the element. So first point is to write down the correct electronic configuration of the element. Now students, second step, that when we have written the correct electronic configuration, the second step will be to identify the block. Now to identify the block, we will just see that the last electron enters in which subshell. Now if it enters the S subshell, it will be known as S block element, right? And if it enters the P subshell, it will be P block. If it enters the D subshell, it will be known as D block element. And if it enters the F subshell, it will be known as F block element. Right? In this way, we will identify the block. Now, the third point is to identify the period. Right? So, to identify the period, we will just check the outermost shell, right? That is the principal quantum number, outermost shell, principal quantum number we are going to check. My students will check the outermost shell, that which shell it is belonging. If it is n equals to 1, outermost shell, right, valence shell. So if it is n equals to 1, the principal quantum number we are going to check of the outermost shell. And if it is n equals to 1, it will belong to first period. If it is second, it will be involving the second period. And if it is involving the third, n equals to 3, for the outermost shell, if it is coming n equals to 3, then it will belong into third period. Now the fourth is to identify the group. Now students, if we have to identify the group, then you will see that the for the S block elements, right? So for the S block element, we are just going to count the number of the valence electron in the S subshell, or we'll just count up the number of electron in outermost S subshell. So why we are saying outermost? Because we will, if that is the outermost which is going to be filled at the last. So it's S subshell. This is S here. How many electrons will be present? For example, here that if we have got sodium, right? So we know that the whether it is 3s1, right? Whether it is 3s1 or it is a 4s1, right? We will only see the, because before that we will have 1s1, 2s1 also, right? But we are going to only see the electrons which will be present in the outermost S subshell. Similarly, for the P block, here student, for the P block, we are just going to add the number of electrons in the p subshell, outermost p subshell, with the with 10. That means it will be 10 plus number of valence electrons, you can write in this way, in p subshell. So p subshell, how many valence electrons are there? We are just going to add. If it will have one electron, it will get 10 plus 1. The group number will be 11. In the same way, if it is having number of valence electron 2, it will be 10 plus 2, 12. Right? And in case of d block element, here students, we are going to add the number of electrons or valence electrons in n minus 1 subshell plus ns, right? Ns valence electrons. Again, I am repeating here, for the d block elements, we are going to add up the number of valence electron in n minus 1 d subshell and ns valence electrons, right? So this is n outermost shell. We can say d subshell valence electron, d subshell, how many electrons are there, plus how many electrons are there in the ns electrons, valence electrons, right students? So in this way we can just predict the period, group and block of the element. So just go through it and then we will discuss few examples. So students, you can see on the board that I have written the element and I have written only the denoted it by alphabets, right? So that you can just predict the position from just seeing the atomic number, or you just know the name also. You can just predict it, and that's why I've written in A and E. It's an unknown element A having the atomic number 16. So you can see on the periodic table also, but that is possible when you are at home and you have a book along with you. But if you, until unless you remember the periodic table, so just seeing the atomic number, right? The common atomic number is possible, but when it is high atomic number, it becomes difficult to just until unless you have learned it, so you will not be easily able to just predict the element and its location in the periodic table, right? So, but with the practice only, you will be able to just identify just by seeing the atomic number also. So just here, the atomic number is given. You have to first write down, the first step was to write down the electronic configuration. So the atomic number is how much? It is 16. So you will write down the configuration of it. So you can write it in the expanded form also. 1s2, 2s2, 2p6. So it is coming how much? 3s2, 3p4. Right? So it is 6, 7, 8, 9, 10, 11, 12, 12 plus 4, 16. So students, we have written down the configuration here, right? So first of all, we will identify the block of the element. So here student, while I was writing, I filled the last electron in the p subshell, right? So it will be a p block element. Then coming to the period. Now student, here the outermost, what is the outermost shell here? It is n equals to 3. We have got first shell, second shell, we have got the third shell here as the outermost shell. So here it belongs to the third period, right? Now the next is that we are going to find out the group of it, right? Group of this element, which group it is going to fall, which we can say the column, right? So here we are going to add 10 plus. Now we have identified the p block element, so it is 10 plus and number of the valence electron. So how many valence electron? Valence shell is third shell, and here it is, we are having 6 electrons. So it is 10 plus 6, so we will get 16. So student, this element belongs to p block, period number 3 and group number 16. Now student, the similar way you will just do this one also. Here first you will write down the configuration. So it is 1 is to 2 is to 2p6, 3 is to 3p6, 4 is to 4p6. So we have written till here. So we'll just cross check once again if you're writing the expanded form. So here it is how much? 6, 7, 8, 10, 11, 12, 12 plus 6, 18, 18 plus 20. It is how much? 30, 36. So here one more will be there. That is 5 is 1. Right? So I think I have just skipped one. That is here. So don't do it in hurry. We just do it in. So it is 1 is to 2 is to 2p6, 3 is to 3p6. So it is 4 is to 3d10. So before we are filling up 3d, we will have the 4 is to here. So it is 4, 6, 10, 11, 12, 18. This is 20, right? This is 30. So you have got 4 is to 3d10. So it will be 4p, how much? 36. And here it is going to be then 5 is 1. So 4, 6, 10, 11, 12, 12 plus 6, 18, then 18, 19, 20, 20 plus 10, 30, 30 plus 6, 36 plus 1. We are getting here 37, right, in total. So students, here which block it is. So you will see the configuration that here the last electron is filled in S subshell. So it belongs to the S block. Right, then you will check about the period. So what is the outermost shell here? Here it is 5. So it is belongs to the fifth period. Now coming to the group. Now you will see that since it belongs to the S block element, so here the since it is an S block element, right, you will see the number of the electrons in the S outermost electron shell, that is only 1. So it is going to belong to group number 1. So students, in this way you will just try to do the to predict the pre-period group and the block of other elements. You can also take the element from the other blocks also, right? So here let me give you example. First, another example here. Let you take an example here. C element. Here it's configuration electronic atomic number. Sorry, let it be 25 here, right? So you will just write down its first its configuration, right? And then you will try to just predict its the block, period and group. So student, just try to do it, that how you're going to just predict, how you're going to first write down the configuration, block and the period. So students, here the Z equals to 25, right? So here we will first write down the configuration. So we have written till here it is 3s2 3p. So it is going to be here 3p6, right? So here it is 4s2 3d5. We will just check it. So it's 4, 6, 10, 11, 12, 12 plus 6, 18, 19, 20, 25. Now since you can see here it's the last electron entered in D subshell, so it will be our D block element. Now from the period number, right? So you will just see here that which period it is going to fill up here. Now here the outermost shell, though students, again I am telling one thing, that I have written here the continuous energy level diagram. So but then also here the outermost shell which is being used is the fourth one. So it is period number is 4. Now the group. So whenever we are writing the group, how we are going to write down? for the d block element. It will be n minus 1 d. So how many electrons are there? It is 5 in n minus 1, and in ns2 we have got 2 electrons. So in total it will be 7. So students, in this way you will just so this element z equal to 25, it belongs to block D. The period number is 4 and the group is 7. Right students? So you will just practice this type of questions too, where you are predicting the, by just saying the atomic number, you will predict the position of the element in the periodic table. So whenever it's position, we are referring it to the block, group and the period number.